Fine. Let's begin. You could understand the three-phase voltage waveform sketching. You need to practice the sketching of three-phase voltage. They may not ask you to draw explicitly, but still, it's better you know the waveform sketching. All right. So today, let us start with something known as phase sequence. Phase sequence. Okay. So what do you mean by phase sequence? First, let me take up the definition. See, we never came across phase sequence in case of single-phase AC circuits. That's because in case of single-phase AC circuits, you have had only one type of voltage and current. All right. Whereas when you come to three-phase AC circuit, you will have three voltages. Okay. And then you will be also having three currents. Okay. Three currents. So that's the reason, this phase sequence comes into picture. So phase sequence definition is nothing but it basically gives the order in which the maximum values of three-phase voltages take place. Okay. It just talks about the order in which the maximum values of three-phase voltages take place. Okay. For example, other day we spoke about the vector diagram, right? So phase sequence is extracted from vector diagram. All right. So let me draw a vector diagram which we had discussed the other day. Okay. So say this is your r-axis. Say this is your y-axis. So that the angle separation between r-axis and y-axis is 120 degrees. And let's say this is your b-axis. All right, imaginary axis. So again, angle separation between r and b is 120, and y and b is also 120. All right. Now let us draw the vector diagram. Okay. So along r, let us project vector Vr, which represents the RMS value of voltage induced in R winding. Okay. Vr. All right. And along Y, let us project Vy. And along V, Vb is projected. Okay. And as usual, these vectors, they rotate with a constant angular frequency omega, okay, in anti-clockwise direction. Okay. Now, you're talking about the rotation, right? So what happens when these vectors, they rotate at every time instant by an angle of 120 degrees. So let us consider the initial position. So initial position is we are getting aligned with our axis. So with respect to the initial position, that is with respect to this r axis, you note down the line name. So along r axis, the line name is r. All right. So at rest, in the sense, in its default position, the reference vector, which is getting aligned with r axis, is r. All right. And then, see, these vectors, they constantly rotate with the angular velocity omega, right? Then you give 120-degree rotation. Okay. So when you give the first 120-degree rotation, what happens is that, okay, so this is your V, say this is your R, okay, and let's say this is your Y. And how much angular rotation you are trying to give? 120. 120 means this is how it becomes. This is how it becomes. 120. Now, when you give 120-degree rotation in anti-clockwise direction, what happens is that the R phase has gone to B phase, and Y phase will come to the R phase, and B phase will come to Y phase. That means to say the vectors are getting displaced by an angle of 120 degrees. So when you give first 120-degree rotation in anti-clockwise direction, what happens is that R is going to move and sit in B place. So in place of R, which vector comes into picture? Y vector. So you write down the value. And once again, you give second rotation, 120 degree. Okay. So now, okay, Vy has come into come in place of Vr. Okay, and Vb will have now Vr value, and similarly Vy will have now Vb value. Right. When you give the second 120-degree rotation, what will happen is this Vy gets pushed and is going to sit in place of Vr. So this Vy will come and sit in place of Vr, and this Vr will come and replace Vb, and Vy gets replaced with basically Vb. Okay. So the vector which is getting aligned with r axis when you give second 120-degree rotation is Vb. Okay. And if you give third rotation, that is, if you rotate the vector further by an angle of 120 degree, what will happen? This B will come and sit here, and this Y will come and sit here, and this R will come and sit here. So again, you will get R. And if you keep on rotating these vectors by an angle of 120 degrees, the following sequence keeps repeating. Since this sequence is, getting repeated after every 360-degree rotation, we call the given phase sequence as RYB phase sequence. So to get the phase sequence, what we have to do is you need to first write down the vector which is getting aligned with the reference axis, which is always R. Okay. And then you keep on rotating the vectors in anti-clockwise direction by an angle of 120 degrees. So when you rotate, in every rotation, the vectors are going to get displaced with one or the other vectors. So thereby, you will end up in getting the phase sequence, okay, of this kind, RYB. Okay. Fine. Now let me consider a different vector diagram. Okay. Let's say, suppose I have a vector diagram of this kind. Same thing, angular rotation is omega. Now you tell me what is the phase sequence of this particular vector diagram. Okay. You can unmute your audio and you can just tell me the answer. So in the initial rest position, which voltage is getting aligned with x-axis or r-axis? VR. So R, correct. And when you give a 120-degree rotation, what happens? In place of VR, which is going to come and sit? VB
B.
is going to come and sit. And when this comes and sits in a VR position, what will happen? VB gets replaced with VR. And VB gets replaced with, sorry, says R. This should have been Y. Should have been Y. I missed it. Okay. So this is VB, and in place of VY, VR is going to sit, and in place of VB, you will have VY. VY. Okay. So VR is getting replaced with V, so it is RB. And when you give further 120-degree rotation, B is replaced with VY, and VR